2.4, like a snowball rolling downhill. Describe how compound interest differs from simple interest. Simple interest is calculated only on the initial principal amount. The interest amount I remains constant throughout the entire period. Compound interest takes into account both the initial principal P and any accumulated interest from previous periods. As time progresses, the interest is calculated on the initial principal and on the accumulated interest from previous periods, leading to exponential growth of the total amount. Growth over time. Simple interest, the growth of the principal amount over time remains linear because interest is only calculated on the initial principal. That means the interest amount I remains the same each period. Compound interest, the growth of the total amount over time is exponential due to the effect of compounding. Each period, interest is calculated on both the initial principal and the accumulated interest from previous periods. This leads to a faster accumulation of wealth or debt compared to simple interest. Simple interest, commonly used for short-term loans like personal loans, car loans. It doesn't significantly affect the total amount due. Compound interest, widely used for investments, saving accounts, mortgages, and other financial products where the interest earned on paid compounds over time, leading to significant decreases in the amount accumulated or owed. Develop compound interest formula. So A equals P times 1 plus R to the power of T. A is your future value, P is the principal amount, R is your interest rate in decimal form, and T is the term of the investment in years. For an investment of $100,000 at 6% interest for 4 years, find the simple interest and find the compound interest if interest is calculated once per year. So first it wants us to find simple interest. That's I equals PRT. So our investment is 100,000. Our rate is 6%, which we know is 0.06, and our time is 4 years. Let's go ahead and plug it in. So we have I equals 100,000 times our R, which is 0.06, times our T, which is 4, and we get 24,000. Alright, so you'll earn 24,000 if you invest 6% for 4 years with simple interest. Now let's think about compound interest. So compound interest, that's A equals P times 1 plus R to the power of T. So our variables don't change. So once per year, that's just saying it's compounded once per year. That's how often something is compounded. In this case, we don't care because it's only once, but we're still doing it for 4 years. So our T, our R, and our P aren't changing. So our total investment that we get back is going to equal 100,000 times 1 plus R, which is 0.06, times T, which is, or to the power of T, which is 4. Alright, so we have 100,000. 1 plus 0.06, that's 1.06 to the power of 4. 1.06 to the power of 4. That is 1.262476696. Do you notice I don't round anything? I write down every decimal. 100,000 times 1.262476696. We get 126,247.696. Since we're talking about money, we're going to round 2 decimal places. So 126,247 dot, since that is a 6, we're going to round it up to 70. So in this case, you would earn $26,247 because we uh, invested $100,000, so we added on $26,247. So compound interest usually is the smart idea for investment return. So general formula for compound interest, A equals P times 1 plus R over N to the power of NT. It's basically the same formula like we did in part B, except now N, that's compounded certain times per year. A is your future value, P is your principal amount, R is your interest rate, T is your investment in years, and N is the number of times that interest is compounded. So types of compound: annually is once a year, semi-annually is twice a year, quarterly is 4 times a year, monthly is 12 times a year, daily is 365 times per year. Let's use the compound interest formula to calculate the following value of 600,000 invested at 5% interest compounded quarterly for 10 years. So since we're talking about compound interest and it's compounded blank amount of times, we're going to be using A equals P times 1 plus R over N to the power of NT. So our P, we invested $600. Our R is 5%, which we know is 0.05. Our N, that's how much we're compounding. We're compounding quarterly. Quarterly means 4 times a year. And how long are we doing this for? We're doing this for 10 years. So let's plug it in. We have 600. 1 plus R over N. Our R is 0.05. Our N is 4 to the power of NT, so to the power of 4 times T, which is 10. Alright, if you have a fancy calculator, you can type it in exactly the way it looks, but if not, let's do it piece by piece. So we have 600, 1 plus, so let's divide 0.05 by 4, so that's 0.0125, and let's go ahead and multiply 4 times 10, because we can do that, we get 40. So we have 600 times, let's 1 plus 0.0125, that's 1.0125, all to the power of 40. Don't forget PEMDAS, so we do the exponent first. So 600 times 1.0125 to the power of 40, that's 1.643619463. 600 times that, we get 986.1716781. And if we're talking about money, that's 986.17. So if you compounded for 10 years and you invest $600 at a 5% interest rate and you compounded quarterly, you will earn $986 back. Formulate effective interest rate. Your effective interest rate equals 1 plus R over N to the power of N, all minus 1. Computing the effective rate of interest, which is the better deal? So you are or have or will soon sign up for a bank account or a credit card or a credit union, and you'll be offered all these details about a savings account and stuff like that. So you're going to figure out which one is going to be the best for me, which one is going to give me the most money with the money I put in. So suppose you want to buy a 5-year certificate of deposit, that's called a CD. You visit 3 banks to determine their CD rates. American Express offers 2.15% annual interest compounded monthly. First Internet Bank offers 2.20% compounded quarterly. Discover offers 2.12% compounded daily. Determine which bank is offering the best deal. The bank that offers the best deal is the one with the highest effective interest rate. Since it says compounding monthly, quarterly, and daily, we know we're going to be using our compounding n times per year formula. So we want to know what the effective rate is compounded a certain time amount every so often. We're going to be using R sub e equals 1 plus R over n to the power of n minus 1. So we have 3 banks that we're comparing. We're comparing American Express, and they offer 2.15% compounded monthly. So American Express, the compound rate is 2.15%, which we know is going to be 0.0215, and it's compounded monthly. So monthly is 12. Your N is how often do you compound. Let's bring them out for each single one. So that's American Express. Let's go ahead and do First Internet Bank. So First Internet Bank, their rate is 2.20%, which we know is going to be 0.022%. And it's compounded quarterly, so quarterly is 4. And now our last one, Discover. Discover has a rate of 2.12%, so we know that's going to be 0.0212. And then it's compounded daily, so there's 365 days. We don't count leap years because guess what? They don't count leap years. Now that we have our rate and our compounded, our n, we can just plug it into our formula. So we have effective rate of return. We have 1 plus blank over blank to the power of blank, all minus 1. And our first blank is r. Our r is 0.0215. Our second blank is n, which is 12. Our exponent is n, which is 12. I'm going to show you how to put this into your calculator because I haven't done that yet for this chapter. So I want to show us how do we plug this into our calculator. So I'm going to show you 2 ways because it just depends on if you have a new calculator or old calculator for TI-84. Again, I only know how to use the TI-84, so if you have a different calculator, you're going to have to look up or go to the Math Lab Center to figure out your calculator. So let's plug this in. We have parentheses 1 plus. Now if you have a new calculator, you're going to hit alpha y equals enter. We have 0.0215 over n, which is 12. Close out those parentheses. It has to the power of 12. And then all minus 1. And we get 0.021713135. So if our rate is 0.02171, that means our rate as a percentage is 2.171%. Now we have to do them for each and every single one of them. Now let's say you have an older calculator. How would we approach this with an older calculator? So with an older calculator, we would have parentheses 1 plus parentheses again 0.0215 over 12. So that's closing out the fraction, that's closing out the parentheses, all to the power of 12 minus 1. Or if you have a different calculator, you can do it piece by piece. So you could do our decimal, so 0.0215 divided by 12. We get a decimal. We know we need to add 1. So we add 1, and that's all to the power of 12. And then that's all minus 1. So you can also do it piece by piece and you still get the same answer. You can take it all as 1, you can do it as a fraction bar with a division symbol, or you can do it piece by piece. Alright, First Internet Bank. Pretty much same setup, but just different numbers. So we have 1 plus blank over blank, all to the power of blank minus 1. And our first blank, that represents r, so our r is 0.022. And our second blank, that's n, that represents 4. And our exponent, we have 4. When you plug that into your calculator, you should get about 0.02218, which we know is going to be 2.218%. Last but not least, we have Discover. So for Discover, it's pretty much the same deal, just different numbers. We have 1 plus blank over blank to the power of blank, all minus 1. And our first blank, our rate is 0.0212. Our compounding is 365. We probably automatically think that Discover is the best because you compound every day. Well, that's only true with simple. When we compound a little more complex things like this, especially effective rate of return, sometimes compounding every day is not going to give us the best rate. When we plug this into our calculator, we get 0.02143, which is 2.143%. So the biggest number that's going to be the best deal. So our biggest number is 2.218%. That means that's going to be the best effective rate of return. Now, what's the difference between effective rate and normal interest rate? Because you hear these words like this is your interest rate, but this is what matters. Effective rate of interest is what matters. So let me tell you the difference. Normal interest, that's actually called nominal interest rate. So nominal interest rate is the interest rate that is advertised or stated on a loan or investment without taking into account the effects of compounding. That's why it's called simple interest. It's where this is your normal interest rate. Here you go. Effective rate of interest is the actual interest rate that is earned or paid on the investment or loan over time. It takes into account your compounding. So simple interest is just advertised regular interest. Effective rate of interest is the actual interest you're earning over a period of time. So you can say, I'm going to do this for 10 years. You're going to earn 2.218% with everything you put in. Present value